In this video, we are going to show that 1 plus 2 plus 2 square plus 2 cubed plus 2 to the 4th plus all the way to 2 raised to the power of n. As you can see, this is a geometric series with common ratio of 2 equal to 2 raised to the n plus 1 minus 1 for every positive integer n. We are going to prove this by using the mathematical induction. So let's get started. Let's start the proof. So we're going to prove that this equation holds for every positive integer n. So we're going to let Pn be 1 plus 2 plus 2 cubed, 2 square plus 2 cubed, and plus all the way to 2 to the n, which is 2 to the n plus 1 minus 1. Okay, and then we will start with the base step. So what is the base step? So we start with n equal 1. Then what do we have? 2 to the 1 plus 1 minus 1 turns out to be 2 to the 2 minus 1, which is 4, and it turns out to be minus 1, which is 3. And as you can see, when n is 1, we're going to have 3, which is the first two terms, okay? Which is 1 plus 2. Interesting. So I do the pattern right now, because when n is 1 and the value of 2 to the 1 plus 1 minus 1 is equal to the sum of the first two terms. Okay, when n is let's say 2, so what do we have? We're gonna have 2 to the 2 minus plus 2 to the 2 plus 1 minus 1, which is 2 to the 3 minus 1, which is 7. Okay, and 7 equal to first three terms. So the first three terms, right, which is 1 plus 2 plus 4. Okay, 1 plus 2 plus 2 to the 2. First three terms. Okay, first three terms, well, it's not n. So when n is 3, we might have the first four terms. So we're going to be 2 to the 3 plus 1 minus 1 equal to 2 to the 4 minus 1, which is 15. So we're going to have 1 plus 2 plus 2 squared plus 2 to the 3. It's like we have 3 plus 4 equals 7 plus 8 equal 15. Okay, great. So when you have n equal to 1, you're going to have 1 plus, right? 1 plus 2 to the 1. Okay, great. Now, so what can we do with this? So I think we have this pattern. When n is 1, we're going to have 1 as the first term and 2 to the 1. And then when n is 2, we're going to have 1 plus 2 to the 1 and 2 to the 2. When n is 3, we're going to have 1. We're going to have 15, which is 1 plus 2 to the 1 plus 2 to the 2 plus 2 to the 3. Okay, great. So that means that, what do we have? That means that we already have P1. Okay, P1, P2, P3. Okay, P3 are all true. Okay, true. Now, we already have the base step, so let's take a look at the inductive step. Okay, great. Inductive step here. So when it's come to inductive steps, we have to assume that P of K is true. Okay, assume that P of K is true for every positive integer K. Okay, and try to show that P of K plus 1 is true. Okay, I just want to use mathematical induction. So from what we have assumed right here, so we're gonna have, so since P of K is true, so what do we have? So we're gonna have 1 plus 2 plus 2 to the 2 plus 2 to the 3 plus 2 to the 4 plus all the way to 2 to the K, which is 2 to the K plus 1 minus 1. Okay, this is our PK. We're gonna have this. We want to show that P of K plus 1 is true. So what do we have? Okay, so what do we have? So we're gonna have, okay, we have 1 plus 2, 2 to the 2, 2 to the 3, plus 2 to the 4, plus all the way 2 to the K plus 2 to the K plus 1. Okay, and we try to have, we try to show that this term right here equal to 2 to the 2 plus to the K plus 2 minus 1. Okay, now we already have the first K terms, which is, okay, let me write like this. We're gonna have 1 plus 2 to the 2 and plus all the way to 2 to the K. Okay, and what does it turn out to be? It turns out to be 2 to the K plus 1 minus 1 plus 2 to the K plus 1 right there. Okay, so these are the same terms, right? So we're gonna have 2 times 2 to the K plus 1 minus 1. Then it turns out to be 2 to the 2 to the K plus 1 n plus 1 minus 1. Okay, it's like you plug in n plus 1 into here. So it turns out to be 2 raised to the K plus 2 minus 1. Okay, so we have shown that P of K is true. Okay, so P of K is true right now. So we have shown the inductive step. Okay, so by mathematical induction, what do we have? So we have proved that we have proved that 1 plus 2 plus 2 to the 2 plus 2 to the 3 plus 2 to the 4 and plus all the way to 2 to the n, which is 2 to the n plus 1 minus 1. Okay, for every positive integer n. Okay, so that's what we have right here. So we have shown that 1 plus 2 plus 2 to the n plus all the way to 2 to the n equal to 2 to the n plus 1 minus 1. That's it for this video.